Imagine standing on the surface of a planet where the sky glows a perpetual shade of midnight. A world cloaked in darkness so profound that it seems to swallow light whole, a stark contrast to the colorful terrestrial lands we inhabit. Welcome to the enigma of the darkest planet ever found. Have you ever pondered what mysteries lie within such a realm? What secrets might reside in the swirling, obsidian clouds that envelope this cosmic giant? If you're captivated by space, the unknown, or the boundless realms of our universe, then you're not just going to want to stick around, you're going to want to know what astonishing discoveries and insights will unfold today. As we journey deeper into the cosmos, it's vital to understand the significance of this darkened orb. Officially known as WASP-121b, this exoplanet rests approximately 850 light-years from Earth and has baffled astronomers and planetary scientists alike. Why does it stand out among the thousands of planets we've discovered? It isn't merely due to its immense size or its scorching temperatures. It's the peculiar darkness that shrouds its surface. Here's a jarring thought. WASP-121b is considered one of the darkest planets ever observed, reflecting less than 1% of all light that hits it. You might be wondering what gives it such a unique characteristic. Well, researchers believe the planet has a thick atmosphere laden with clouds composed of metallic vapor, mainly iron and magnesium, reflecting almost no sunlight back into space. Imagine the implications of a planet that seems to absorb the very essence of brightness. Curiosity fuels discoveries, so let's delve into what scientists have pieced together about this otherworldly entity. WASP-121b is categorized as a hot Jupiter. This classification refers to gas giants that orbit very close to their parent stars, resulting in extreme surface temperatures, over 4,000 degrees Fahrenheit, if you can believe it. That's hotter than most stars. At such staggering temperatures, one would expect dazzling scenery, glimmers of light, or vibrant clouds, yet what we see is effectively a void. What's even more intriguing about WASP-121b is its unique atmosphere. Unlike other hot Jupiters, this planet is entirely shrouded in those metallic clouds, leading to a bizarre weather system that has scientists scratching their heads. On Earth, we think of atmospheric pressure as a force that helps sustain life. Here, the atmospheric conditions might create storms of molten metal, swirling around in the darkness. The likely existence of such rain challenges our traditional understanding of planetary atmospheres. Take a moment and let that sink in, rain made of molten metal. What comes next will leave you speechless. Imagine the cacophony of metallic droplets hitting the ground, echoing through a landscape devoid of light, yet full of wonder. Would you dare to stand there? Now, let's consider the human fascination with darkness itself. Throughout history, darkness has frequently been associated with mystery, fear, and the unknown. From ancient mythology to modern sci-fi stories, darkness can evoke curiosity as much as trepidation. We have lore and legends that weave tales of shadowy realms, yet here we are, experiencing a real dark planet that eludes comprehension. Could this planet serve as a mirror reflecting our deepest fears and our insatiable desire to explore the extremities of existence? The discovery of WASP-121b illustrates that the universe offers endless surprises, inviting us to challenge our preconceived notions. When astronomers first detected this planet in 2018, it baffled scientists, urging them to rethink the planet formation models. It defied expectations in terms of chemistry and atmospheric dynamics. This confirmation of freshly minted theories regarding planetary development not only adds depth to our understanding of exoplanets but also prompts more questions. But it doesn't stop there. The researchers are keen to investigate how the extreme proximity to its host star affects the planet. For example, seeing as WASP-121b is tidally locked, one side perpetually faces its sun, basking in a relentless orange glow, while the opposite side drifts into eternal night. What might this mean for any potential weather systems? Could life even thrive in such contrasting conditions? So, what happens on the sunlit side of a world shrouded in darkness on one half? You might assume it's a world of heat and chaos, but researchers suggest otherwise. The glowing, fiery atmosphere might create inexplicable phenomena, intertwining violent storms with the chilling silence of the dark side. We might be looking at an earthy parallel of stark divides, one side radiant with energy and the other eternally quiet. With each curious thought, we peel back layers of understanding, beckoning more questions than answers. Picture this extraordinary contrast: rivers of molten lead streaming across a hellish landscape bathed in endless sunlight, while the other side creates a realm of enduring shadows. Together, these elements compose a cosmic tapestry highlighting the remarkable and often bewildering interplay between light and dark. Could there be a lesson in this duality? Perhaps it serves as a reminder to embrace the complexities of existence. The thrill of knowledge comes not merely from the light that reveals, but from the shadows that challenge our perspective. This celestial juxtaposition of radiance and obscurity begs the question: in the grand scheme of the universe, are our fears of the unknown misplaced? You might be pondering how scientists actually explore these distant worlds. The advancements in technology and observation techniques have opened previously barred doors to the cosmos. Telescopes like the Hubble and the newer James Webb Space Telescope are enabling clearer looks into the depths of space, unveiling fascinating worlds. These intricate instruments scour the shadows and brilliance, painting a more comprehensive picture of the universe, one observation at a time. Have you ever considered the implications of discovering darker planets compared to their brighter counterparts? The findings may alter our understanding of habitability criteria. While we might assume that life flourishes in sprawling sunny landscapes, dark realms challenge our perceptions. We should ask ourselves, what hidden forms of life could potentially exist in realms of perpetual darkness? The mystery keeps unfolding as scientists hypothesize whether other dark planets exist in the universe. If we take into account the myriad of star systems, it's logical to infer that we may discover even darker celestial bodies than WASP-121b. With the universe possibly extending beyond our imagination, is there an even greater enigma lurking out there? Hold on as we take a detour from WASP-121b and explore other dark planets like Trace-2b and its unbelievably dark surface, a world that captures only 0.1% of visible light, making it the darkest exoplanet recorded before WASP-121b. Trace-2b features a deep black atmosphere, absorbing virtually all light, including visible light, ultraviolet, and even infrared. Imagine this dark titan drifting aimlessly in the void, bathed in mystery. It raises questions regarding the composition of its atmosphere. Scientists speculate whether the presence of sodium and potassium in vapor form encourages the extreme blackout. This puts a spotlight on how distinct exoplanets influence each other amid the cosmic balance. As we move deeper into our exploration of darkness, let's reflect on the broader implications. What does it mean for humanity's quest to understand our universe? Might these planets be the key to unlocking greater truths about how celestial bodies interact with one another? Or whether life, as we know it, might emerge under conditions we couldn't fathom? Our journey through the cosmos has just begun, but it leads back to a bigger picture. These dark worlds force us to confront our own ignorance and assumptions about life and existence. Every mystery solved births new enigmas demanding resolution, leading to an insatiable hunger for knowledge. Could this dark planet, with its bewildering attributes, inspire future explorations? You may be asking yourself what lies ahead, what discoveries await us in the dark expanse. As we navigate through these planetary enigmas, let's remember the beauty of discovery, the enthrallment of the unknown, and how we, too, are explorers made for this cosmic quest. So, as we transition into the next phase of our exploration, think about the stories we've unearthed about WASP-121b and its peers. We'll continue to unveil more about these dark planets, the science behind their mysteries, and perhaps encounter life-defining revelations that can shift our perspectives forever. Hold on to your curiosity, because the journey is far from over. Let's see what awaits us in the shadowy depths of the universe. The allure of darkness has always fascinated humanity, invoking mystery, adventure, and the yearning to uncover hidden truths. As we traverse back into the cosmos, let us dive deeper into the implications of dark worlds like WASP-121b and TRACE-2b, exploring how they challenge not only our understanding of exoplanets but also our very notion of life beyond Earth. One concept that emerges prominently amidst our exploration of these shadowy realms is the potential for uncharted life forms to exist within extreme environments. Historically, scientists have often positioned life as needing certain conditions to flourish, specifically, water, a stable atmosphere, and moderate temperatures. However, as we learn more about planets like WASP-121b, we start to realize that life may not adhere to our tailors of convenience. Consider extremophiles living in Earth's most inhospitable climates, organisms thriving in scalding hydrothermal vents or existing in freezing temperatures in Antarctica. Could these resilient beings offer a window into what life could look like under the oppressive conditions of dark planets? Researchers increasingly posit that life can endure in harsher settings than previously imagined. The existence of dark, metallic rain on WASP-121b, albeit traumatic for life as we know it, may still spawn unknown biochemistries that could lead to organisms perfectly suited for survival. Imagine a microbe that has evolved to metabolize metal vapor rather than organic compounds. The planet's extreme weather could generate entirely new ecosystems, rich in life forms we haven't even begun to fathom. This radical viewpoint compels us to expand our definitions of habitability and rethink our search for extraterrestrial life in the cosmos. In our quest for knowledge, we cannot dismiss the importance of studying other dark exoplanets systematically. Some researchers are already exploring the potential for dark planets to possess habitable moon systems, recognizing that their natural satellites may provide an altogether different environment. Imagine a moon orbiting a dark gas giant, potentially bathed in light from a distant sun while the planet itself remains cloaked in darkness. These moons could display conditions that are far more suitable for life, unearthing a new dimension to planetary exploration. Amidst this burgeoning understanding of dark planets, exciting technological advancements are underway that may help us probe even deeper into their mysteries. The success of the James Webb Space Telescope has opened new eyes to the cosmos, allowing astronomers to study planetary atmospheres, analyze chemical compositions, and gain insights into the thermal characteristics of potentially habitable worlds. As we continue to refine our instruments, we'll enhance our capabilities to explore places we once considered unreachable. For instance, the upcoming missions proposed by various space agencies aim to focus on the atmosphere and climate of exoplanets like WASP-121b. These missions will strive to detect signatures of biosignatures, chemical signals indicative of life. As we catch glimpses of these distant worlds, weaving narratives about their possible ecosystems and climates, we find ourselves fueled by hope that we may discover life existing in places we thought impossible. Yet, the revelations associated with these dark worlds extend beyond the scientific and existential. They encourage reflection on the nature of exploration itself. This is not merely about uncovering new planets or civilizations, it is about our own journey as seekers in a universe that teems with enigma. With each dark planet we unearth, a mirror reflects our innermost questions and illuminates what we seek, not only answers but a deeper understanding of our place among the stars. So, as we investigate the depths of these strange worlds, let's broaden our horizons beyond physical exploration. Dark planets invite us to contemplate the philosophical implications of our existence in a vast universe. They challenge established narratives about light and dark being dichotomous and force us to acknowledge that shadows harbor knowledge begging to be unearthed. This journey through the cosmos also mirrors the dualities present in our lives. The concept of light symbolizes knowledge, certainty, and hope, while darkness reflects fears, the unknown, and limitations. But perhaps we should reconsider darkness. Its infinite expanse offers introspection. From the void can emerge creativity, resilience, and new understanding. Now, let us pivot back to our fascination with these utterly unique worlds. Every time we set our sights on WASP 121b or Trace 2b, we aren't just looking at celestial bodies, we're looking at key puzzle pieces that represent broader cosmic cycles and interactions. Each dark planet contributes to the understanding of how matter behaves under extreme conditions, how systems evolve over time, and how celestial bodies, whether dark or light, interact across renditions of time and space. The canvas of our understanding is continually being painted with strokes of darkness. As we push our explorations further, the cosmic dialogues we engage in beckon essential conversations about our future. The questions remain: how do we adapt our theories? What tools will we forge to engage with these mysterious worlds? With new discoveries awaiting us, our explorations will inevitably cycle back into ourselves, challenging us, enlightening us, and redefining our relationship with the universe. Eventually, a singular realization emerges. Our connection to these dark planets is more than scientific, it reflects our intrinsic desire to explore, understand, and fundamentally relate to the cosmos. Each journey into the unknown reinforces our shared identity, a species yearning to break through darkness into light. In conclusion, as we step away from the shadowed realms of WASP 121b, Trace 2b, and beyond, let us carry forward the wisdom of those experiences. Every meteor shower, every telescope dive, every question posed becomes a note in the symphony of cosmic exploration. Ultimately, the darker planets inspire us to look beyond what is visible, to find beauty in obscurity, and to nurture curiosity amid uncertainty. The universe is vast and likely more complex than we can even comprehend. However, by daring to ask questions and pursue exploration, we can engage with its enigmatic nature, resonate with its mysteries, and find purpose in our quest for knowledge. The essence of humanity thrives in exploration. Unlocking new realms will forever remain an anchor as we chase the shadows of the cosmos. After all, it is in the intricacies of darkness and the allure of the unknown that we may find our true light. So, whether you ponder the rain of molten metal on WASP 121b or contemplate the shadows of Trace 2b, remember, the next great journey lies not in what we have discovered, but in the wonders yet to be encountered. The vast, dark ocean of stars invites us, beckoning us to keep exploring, to keep questioning, for there is so much still to learn, and the universe, in its remarkable expanse, is waiting patiently for us to uncover its lost tales. Let us continue to strive for understanding, for the journey is far from over, and the universe, with all its shadows, holds infinite possibilities yet to be revealed.